Number 3, hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time t, where t is between 0 and 6, is given by a differentiable function c, where t is measured in minutes. Selected values of c, measured in ounces, are given in the table above. All right, so A, use the data in the table to approximate C prime of 3.5, show the computations that lead to your answer, and indicate units of measure. All right, so if we would like to find C prime, that's going to be the derivative at 3.5, which will be happening between 3 and 4. So we've done this several times where we'll take the slope, so we're going to do 12.8 minus 8.8, 11.2, and then divided by 4 minus 3. And when we do that, that will give us 1.6. And we do have to label it the C1 on top, so the ounces is going to go first and then the minutes. So it's going to be ounces per minute. I did show the computation, and I did indicate units of measure. That was worth 2 points. For the 1.6, I got a point, and for the ounces per minute, we would have gotten a point. Okay, part B. Is there a time between 2 and 4 for the t value at which the derivative is equal to 2? Justify your answer. Okay, they're asking me, is there a spot where the derivative has to equal 2? And then I notice that they're giving me an interval, which to me, in my mind, is saying something about an average rate of change or a slope. So they're asking me, is there somewhere where the slope is going to equal 2? So, or the derivative will equal 2. To me, in my mind, this is drawing up the mean value theorem. As long as the function is continuous and differentiable, which it said it is, if it's differentiable, it has to be continuous, then we know there's some place where the slope has to equal the derivative. So if we can find somewhere where the slope is equal to 2, that means the derivative at there would also have to equal 2. So looking at this, if we use, and it's between 4 and 2, so if I use the 4 and the 2, and I find the slope between those two, and it equals 2, then we'd know by the mean value theorem the derivative would have to equal 2. So if I find that slope, I'm going to get slope is equal to 12.8 minus 8.8 over 4 minus 2. That will give me 4 over 2, which does equal 2. So since I found out that the slope between 4 and 2 is equal to 2, and the mean value theorem holds, I know that the derivative also has to equal 2. So I'm going to say, is there a time? Yes. I'm going to say the mean value theorem guarantees that somewhere the slope will equal the derivative, and I found a slope of 2, which means there must also be a place where the derivative equals 2. And that was a little bit wordy. I'm guessing I could have shortened it up a little bit, but that's what I would do. All right, for part C, it says to use a midpoint sum with 3 subintervals of equal length, finally, indicated by the data in the table, to approximate the value of 1/6 the integral of 0 to 6 c of t. Using correct units, explain the meaning of this in the context of the problem. So, number 1, use a midpoint sum. Number 2, explain the meaning. Okay, so the first thing that we're going to do is use a midpoint sum. We actually get to use equal length, and it is a midpoint sum, so keep that in mind. First thing that I like to do, I'm starting at 0 and going to 6. If I need to use 3 subintervals, I've got 6 minus 0 will be 6, and I have to go 3 intervals, so that's going to make me go by 2's. Okay, so I'm going by 2's, and when we do this, when we do a midpoint sum, since I went by 2's, I'll put a 2 on the outside. And then if I'm using the midpoint between 0 and 2 would be 1, so I'll be using this value, so I'll be using c of 1, plus halfway between 2 and 4 would be 3, so I'll be using c of 3, and then plus halfway between 4 and 6 would be the 5, so I'll be doing c of 5. Okay, so from here we're going to get 2. C of 1 was equal to 5.3, C of 3 is equal to 11.2, and C of 5 is equal to 13.8. So if I add those together, I will get, this will all be 60.6. Please notice though, I did have to find 1/6 of that. So I'll have 1/6 times that, and that will end up being 10.1. And since I was taking the integral of c of t, it said when I'm taking 1/6 of that, this is going to be 10.1 ounces. So it does ask me now to explain the meaning of that, and I know that this is going to be 1/6. That's an average value, so it's going to be the average value of C. So it's going to be the average number of ounces. So I'd say 1/6 C. This represents the average number of ounces of what? C stands for coffee. Oh no, hot water actually. Number of ounces of hot water. And what is the hot water doing? It's dripping through the coffee maker. Oh, no, wait. Just a second. The amount of coffee in the cup. So the average number of ounces of hot water in the cup over the interval 0 to 6 minutes. Okay, so I believe that is the average amount of coffee in the cup in ounces over the time interval 0 to 6 minutes. So I think I covered everything. I said I included units in ounces over 0 to 6 minutes, and that's just the average number of ounces. All right, so I think I did everything there. That was worth 3 points. 1 point if I did a midpoint sum, 1 point if I got the right answer. So don't forget we have to multiply by that 1/6 to get the right answer, and then 1 point for my interpretation. So this part was worth 3 points. And then part D, the amount of coffee in the cup in ounces is modeled by the function b of t equals 16 minus 16e to the negative 0.4t. Using this model, find the rate at which the amount of coffee in the cup is changing when t equals 5. So if it's asking me for the rate at which the coffee in the changes, it's asking me for the derivative. So this problem is asking me actually just for b prime of 5. And so first of all, we don't get to use our calculator this time, so I first of all need to find b of t. So if I find the derivative of this, the derivative of 16 is just 0. And then the derivative of this would actually be negative 16e to the u. The derivative of negative 16e to the u would be negative 16e to the u du. So it's going to be negative 16e to the u times du. Du, the derivative of negative 0.4t is just negative 0.4. And then if I simplified that out, negative 16 times negative 0.4 is going to give me 6.4 e to the negative 0.4t. And then we did want to find out how fast the amount of coffee in the cup was changing when t equals 5. So to find b prime of 5, we'll plug in 6.4 e to the negative 0.4 times 5. And I'm guessing we actually could probably keep our answer like that. I'm just going to go one step further. It's going to be 6.4 e to the negative 0.4 times 5 would end up being 2. So you could either leave your answer like that, or we could make it 6.4 over e squared. I'm sure either one of those is fine. And if I'm looking for a rate at which the amount of coffee in the cup is changing, it should be ounces per minute. And that was worth 2 points. 1 point for finding the derivative correctly, and then 1 point for finding it at 5. So there we go once again.